Today's lesson is over section 5.6, integration by parts. Now, we've already talked about U substitution when we have chain rule. Here, this possibility is when we have the product rule in play. And so normally, for when taking the derivative, you would take the derivative of the first times the second plus the derivative of the second times the first. And so using that as an idea with the integrals, we want to kind of rewrite this. So this is our kind of proof of how this works. So as it stands now, product rule would be pretty hard to do the integral, but as we move things around, and if we say u is f of x and v is g of x, and then we represent du and dv as their derivations, we can rewrite the integral into that notation of the integral of u dv is equal to uv minus the integral of v du. So in order to do this, we need to set u equal to one particular part of the function. So here I say u is equal to x, take that derivative, so du is equal to dx, or like 1 dx. Then the rest of it needs to represent dv. So in this case, sine of x dx is dv, and then take the antiderivative of that, which is v equals negative cosine of x. That allows us to get all the pieces, and that allow us to use this kind of format that we have for our product rule. And so here it's u times v, which in this case is x times negative cosine of x, and then minus the integral of v times du, and so that is negative cosine of x dx. And so once we have that, we're able to kind of simplify, because what we've already taken out doesn't need to be taken, or our integral doesn't need to be taken. And then the other one that we have left, we should be able to kind of simplify. Now, not always, but we should be able to. So the integral of cosine of x is sine of x, and I'm able to get my final answer there of negative x cosine x plus sine x plus c. Then for letter B, we'll say that u is equal to ln of x. So the derivative of that is 1 over x dx. Now here, since there's not another piece there, we can say that dv is equal to dx, and then we can go backwards and say v is equal to x. The reason we use it for ln of x here is because we don't have a integral of ln of x at the ready, so that's why we kind of use it this way. And so here uv is ln of x times x, and then the nice thing is for the integral x times 1 over x is just 1. So then that integral is pretty easy, which will just be x. So my final answer will be x ln of x minus x plus c. All right, so for letter C, we'll say u is equal to e to the x, and then the derivative is still e to the x dx. Dv will be sine of x dx, which the antiderivative is negative cosine of x. So we'll plug those in. Now the difficult thing about this one is that for cosine and e to the x, their variables don't get rid of. They keep repeating themselves. The e to the x is always itself for any antiderivative. Cosine of x is always like an iteration of sine and cosine every time. So here we kind of have to do some an extra set of this rule, integration by parts. So we do it again. So e will be n, take that derivative. dm will be cosine of dx, antiderivative of sine of x. And once I do it again, that'll give me the integral of sine of x times e to the x dx, and that is actually the original thing that we started with. So in this case, because we kind of have like terms and we don't write it on the other side of the equal sign, technically it's over there. So I'm going to add it to the left and move it to the other side. And that gives me 2 of them. So I can say 2 integral of e to the x sine of x dx is equal to all the stuff that I have on the right. And then I can divide both sides by 2. And that allows me to find what my actual answer is. So I'll say that e to the x times cosine of x plus e to the x times sine of x is all divided by 2 plus c. That'll be my answer for letter C. Letter D here, we'll say that u is equal to x squared which is up in the e part, and the derivative is 2x. Now, notice that we have x cubed out front, so we're going to use u substitution here to help us out. So we can kind of rewrite this so that we can make these a little simpler. And so notice that we have 2x squareds, so we'll actually have 2 u's. And so we'll be able to rewrite this so it's u times e to the u, and then that 1/2 that we had to insert in, we'll get to move out front. And now we can use integration by parts so that we can rewrite this, and that allows us to be able to kind of manipulate it and get rid of that 1u in front, and allow us to get an integral with just e to the u at the end. And now notice that both of these have the 1/2 to them, so I have to distribute that through. Okay, so the antiderivative of e to the u is e to u, and I plug that in, and now all I have to do is go back and plug in what u is representing, so which is x squared, and so I plug that in and get my final answer. Now, same thing with u substitution. I'm going to have definite integrals with these. Now, I don't have to change the values unless I use u substitution. So our 0 to 1 and 4 to 9 will stay the same if we don't have to use substitution rule here. So for this one, the inverse tangent of x we'll set as u. That is 1 over x, or 1 over 1 plus x squared is my derivative. And then I plug these in. Now notice the difference here is when you use this rule, now when I take the u times v, that is going to be from 1 to 0. So I actually have to plug in those values. And then once I find the integral of x times 1 over 1 plus x squared, so here I have to use u substitution, which will change my values. So I go from 1 to 2 now, after I plug those in. But then that allows me to get 1 over r times 1/2 dr. I can move that 1/2 out front. Now for inverse tangent of 1 and inverse tangent of 0, we just get pi over 4 minus 0 there. And then I can take the antiderivative of 1 over r. Allows me to get ln of absolute value of r. Remember that ln of 1 is 0. And so here I'm able to get pi over 4 minus 1/2 ln of 2. Okay. Same thing for letter F. I want to rewrite this first so I can kind of see what I need to do. And so it looks like I can say that u is equal to ln of y. And both, like, it doesn't matter which one is u and which one you start with dv. You can kind of move them around. So here I chose to do ln of y because if I didn't and I was asked to do the antiderivative of ln of y, that would be a lot harder because I don't have that at the ready. But I do know what the derivative of ln of y is, which is 1 over y. So I chose to take that path just to make my life a little easier, then kind of using the rule again. Now here, there's a lot of things that don't really super simplify. With the 9 and 4, I can plug them into the radical and get perfect squares, but with the ln, 9 and 4, they're not really super nice to each other. So I'll have to leave them as such, which is okay. Taking the integral of y to the negative 1/2, that gets me 2y to the 1/2, which we already kind of proved up in the earlier part, and then doing the integral there. So doing all the simplification allows me to get the answer of 6 ln of 9 minus 4 ln of 4 minus 4. And that's the lesson. Okay, have fun.